Welcome to Creative World. In this video, we will solve Chapter 3 Learning Assessment E3.9. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Learning Assessment E3.9. Find the value of current I0 in given below figure using nodal analysis. This is the circuit diagram of given problem. Inside this network, we have to find the value of current I0 through this 2 kilo ohm branch. So without wasting time, let's proceed towards the solution. Before starting the solution of this problem, if we observe inside this network there is a voltage source exists between two non-reference nodes. So this problem cannot be solved using simple nodal analysis technique. In order to solve this problem, we have to adopt supernodal analysis technique. Before applying supernode analysis technique, first we have to learn the concept of supernode analysis. If you already know its concept, you may skip this part of the video. Here I am taking a reference circuit diagram for the understanding of supernode analysis concept. In order to apply supernode analysis technique, we have to remember a solid key point. If a voltage source exists between two non-reference nodes, then supernode analysis technique will be applied to solve that problem. And in order to apply supernode analysis technique, we have to merge that voltage source to any one of its adjacent node voltages. Whenever we will merge voltage source to its adjacent any node voltage, that node will act as supernode. Now we will learn about how the voltage source is merged to its corresponding node voltage. For better understanding, we will take this part of the circuit in order to form a supernode. Here a 12 volt source exists between two non-reference nodes. Now as we are dealing in simple nodal analysis technique, voltage across any element between two nodes is always equal to the difference of those two node voltages. In this case, voltage across this voltage source is 12 volt, which is indicating that the potential difference of these two node voltages is 12 volt. So we can write this statement in mathematical form. Potential difference of these two node voltages is equal to 12 volt. We will consider both cases, and in both cases the voltage equations will be same. In first case we are considering voltage V2 is on higher potential than voltage V3. So the direction of current will be from V2 to V3. V2 minus V3 will be equal to minus 12 volt. Here the direction of current is from this node to this node and current is entering from negative terminal. That's why this 12 volt is taken with negative sign. Now if we want to merge the value of this voltage source towards this node V2, then using this equation, the equation of voltage for V2 will be equal to V3 minus 12 volt. Similarly, if we want to merge this voltage source towards V3, so using this equation again, the equation for this node voltage V3 will be equal to V2 plus 12 volt. Now we will consider another case where voltage on V3 is on higher potential than voltage V2. In this case, voltage difference between these two node voltages will be equal to V3 minus V2 equal to plus 12 volt. Here V3 is on higher potential than V2. It means the direction of current is from V3 to V2 and the current entering terminal is positive. That's why this 12 volt is taken with positive sign. Now using this equation, we can merge this voltage source either to V3 or V2. if we merge the value of this voltage source to node V3, then using this equation V3 will be equal to V2 plus 12 volt. Similarly, if we merge this voltage source into node V2, then V2 using this equation will be equal to V3 minus 12 volt. You may see that in both cases the equations for V3 and V2 are same. After calculating node voltage equations including voltage source value, we can form supernode on these 2 points. In this first diagram, 12 volt source is merged with V3 and V3 is replaced with its equation V2 plus 12 volt. Similarly, in this second diagram, 12 volt source is merged with V2 and V2 is replaced with V3 minus 12 volt. After merging the voltage source to either node, this node will act as supernode and it will be considered a single node inside the network. Now move back towards the problem. First of all, in this circuit we will form a supernode by merging this voltage source to either this node or this node. So we will take the difference of these two node voltages, that is V2 minus V3 equal to minus 12 volt. Here V2 is considered on higher potential than V3, which means the direction of current is from V2 to V3. So current is entering from negative terminal of this voltage source, that's why this 12 volt is taken with negative sign. Now we want to merge 12 volt source to this node V3. So node voltage V3 using this equation will be equal to V2 plus 12 volt. Now we can modify the network by removing this voltage source and replacing this V3 with V2 plus 12 volt. And these two nodes are converted into a single supernode. Now inside this network, these two nodes will act as single node and it will be treated as supernode. Now inside this network only two nodes exist. One is reference or ground node and other one is supernode. So we will apply nodal analysis technique on this supernode to calculate the value of current I0. For that purpose we have to assume and label all unknown branch currents along with their directions. I am assuming these currents with their specified directions. Next step is to apply Kirchoff's current law on this supernode. On this node, two currents are entering, I1 and I4, while two currents are leaving, I2 and I3. Leaving currents are taken with negative sign. In next step, we have to replace these currents with their respective equations. Current I1 will be equal to 6 volt minus V2 divided by 2 kilo ohm. The direction of current is towards V2, which is indicating that 6 volt will be on higher potential than V2. Similarly, current I2 will be equal to V2 divided by 1 kilo ohm and it is taken with negative sign because it is leaving current. Now current I4 will be equal to the potential difference of these two voltages divided by the resistance. Here the direction of current I4 is towards this node, which is indicating that minus 4 volt will be on higher potential than this node voltage, which are V2 plus 12 volt. So the equation of current I4 will be minus 4 volt minus V2 plus 12 volt divided by 2 kilo ohm. Similarly, current I3 will be equal to V2 plus 12 volt divided by 2 kilo ohm. Here you have to notice a point. Although this is a single node, but voltage on this side of node is V2 and this side of node is V2 plus 12 volt. So whenever we will be dealing currents associated with this node, we will be taking node voltage as V2 plus 12 volt. And whenever we are dealing currents associated with this node, we will be taking node voltage as V2. Now we will solve this equation. First of all, open these brackets. It will become minus V2 and minus 12 volt. In order to omit all denominator values, we will multiply this equation with 2 kilo ohm on both sides. This 2 kilo ohm will cancel out with the product of 2 kilo ohm. Only 6V minus V2 will left. Here 1 kilo ohm will cancel out with 2 kilo ohm. only 2 will left, and that 2 will be multiplied with V2, it will become 2V2. Similarly, 2 kilo ohm will cancel out with this 2 kilo ohm, only minus 4 volt minus V2 minus 12 volt will left. Here the product of 2 kilo ohm will cancel out with 2 kilo ohm in denominator, only minus 1 will left, and that minus 1 will be multiplied with V2 and 12 volt, it will become minus V2 minus 12 volt. Now add constants together, minus 12 volt will become minus 24 volt, and minus 4 volt will become minus 28 volt, plus 6 volt will become minus 22 volt. Similarly, sum of variables including V2 will become minus 5V2. Now inside this equation only one variable exists, that is V2, and we are interested to calculate its value. So place minus 5V2 on the other hand side of equal to make it positive. Now divide on both sides with 5 to calculate the value of V2, that will become minus 4.4 volt. After calculating the value of voltage V2, we are able to calculate voltage on this node, that is the sum of V2 and 12 volt. So voltage on this node will be minus 4.4 volt plus 12 volt, that will become 7.6 volt. Now we have retrieved the value of this node voltage, that is 7.6 volt. So using Ohm's law we can calculate current through this 2 kilo ohm resistance, that will be equal to 7.6 volt divided by 2 kilo ohm. So the value of current I0 inside this network will be equal to 3.8 milliampere. So this was chapter 3 learning assessment E3.9. Thank you. See you again in next video.